Welcome to Dare, the show for innovators, entrepreneurs, and startup leaders who dare to shape the future. Your hosts today are Ned Hayes and Cecilia Mariani. Dare is brought to you by Darwaf, the superpower tech team that can make your vision a reality. The Dare podcast is excited to welcome Kordel France to the show today. Kordel is the CTO and co-founder of Theta Diagnostics, and they have the great idea of giving a sense of smell to machines. Kordel has a fantastic background in multi-modal AI, nanosensing technology. He's been a key inventor for a number of great companies in the past. He's also an advisor to multiple startups. So welcome to the show, Kordel.
Thank you for having me, and thank you to your audience. I'm excited for a fun conversation.
Yeah, well, I'd love to know, first of all, tell us about Theta. Like, what are you doing there? This sounds really interesting.
Yeah, so you led it well in your intro. The one-liner is Theta Diagnostics is effectively giving the sense of smell to machines. So we have a series of sensors that effectively act as electronic noses, and they can detect a variety of compounds in the air. And there's a variety of applications that we're looking at right now, but they effectively enable a sense of smell for artificial intelligence. So if you look at like a camera, that's like an artificial eye, a microphone's an artificial ear. We're trying to build an artificial nose.
Right. What I find really interesting is that the more sensors you add, the more the machine has a full kind of context-rich view of the environment, right? So like smell by itself is insufficient, but smell combined with vision, combined with audio, like all of that creates a kind of full spectrum experience, right?
Yeah, you're totally right. It's that multimodal learning, that sensor fusion really comes in to give machines a better sense of their environment and more better situational awareness. The argument I hear a lot recently is with AGI and artificial general intelligence and whether or not that is actually representative of human intelligence. And our argument is that if you want to replicate human intelligence, you need to have all five senses into an AI machine or a human or a humanoid robot or whatever it is. And we want to contribute the sense of smell.
Fascinating. Yeah. So I'm curious, like you have a background where you worked as an AI architect at Toyota, you worked at Lockheed Martin. Tell us how you came to working on Theta here.
Yeah, so my background fundamentally as an engineer, I actually started as a mechanical engineer and then moved into software and autonomy and robotics. It actually started when I was really a kid, as just a child. So I grew up on a farm,
Hmm.
and my father had some self-steering software for these tractors powered by GPS. And so you see these giant machines as a kid driving themselves. And it's something straight as a sci-fi movie when you're 4 years old and there's giant tractors driving themselves. And
Yeah.
so I asked my father, I go, how do I work on these things? How do I contribute to, these robotic machines? And he says, you got to be good at math. You need to focus on that and become, really good in various engineering disciplines. And that's kind of what started my career from there is I started trying to be very good at math, and that led into engineering in high school and college and some jobs working in sensors and aircraft and robotics in various industries. And eventually I led me and my co-founder to the point where we decided that there was some asymmetry being developed in artificial intelligence and not enough effort being given to some senses, one of them being the sense of smell. So we decided to do something about it. And that led to Theta.
So could you give us some scenarios where smell could be used by machines? I assume defense or other scenarios.
Yeah, so there are a variety, right? Like if you think of you and I can smell bread being baked, right? But our sensors allow you to go a little bit further. So instead of sensing smell being baked, we can break it down and to say, well, there's acetone at 20%, there's heptane at 84 or 18%, there's benzene at 38%, whatever. So we can go to a level and actually break down the chemical compound and chemical structure. So there are a couple industries where that's appealing. One of them is the healthcare industry, actually, because we can use that to look at people's breath. So
Hmm.
your breath, when you exhale, you emit several thousand compounds that all give a specific indication of what's going on in your body. And so we can detect certain medical conditions with our sensors by just using them to smell breath. One of them right now is lung cancer. We're going through a clinical trial for that. Those same sensors can actually be used if you put them on like a drone. They can be used to detect drugs or explosives potentially. So there's a lot of applications that they can be used in. It's quite versatile in the number of compounds it can detect and the number of use cases that we can use it in.
Right. I'm reminded of the scenarios where dogs can both smell drugs, but they can also smell cancer, right? And so
Yes,
you're developing a smart nose, much like a dog, that can distinguish patterns that maybe the human brain can't distinguish.
absolutely. Yeah, a dog's nose doesn't get enough credit. It's honestly got so much intelligence baked into it, right? A very significant part of a dog's brain is attributed to olfaction or smelling. We have a
Mm,
much smaller part of our brain. If you look at the resolution that a dog can smell in, it's at 1 part per quadrillion for
mm.
some compounds, especially for something like a German Shepherd, which so 1 part per quadrillion is extremely sensitive. That means if you have a quadrillion air particles, a German
Wow.
Shepherd only needs one to pick out the scent. Our
Yeah.
sensors aren't quite that good yet. They're much better than everything else on the market, but we're at 1 part per trillion, and we're still not as good as dogs. But we can still detect several different compounds at a much finer resolution than other competing sensors on the market.
Right, right. Well, so I'm traveling this week, so I'm on the road, and of course I have to go through TSA regularly, and there's sometimes there's dogs there smelling things, and I don't carry any drugs, so I'm fine. But it did make me wonder about the ethics of detecting something from a distance. And I know that you've spoken before about biometrics and ethics, and so what kinds of safeguards do you have on your technology to make sure that it won't be misused?
So we have a large AI platform behind our technology, and we have several safeguards that go into the sensors. So the sensors by themselves are not necessarily super capable, but they're enabled by the AI technology. So we're studying a lot of what's going on with human AI alignment and the ethics behind artificial intelligence development, what's going on with Anthropic, various organizations within DeepMind, et cetera, to make sure that we're building in the same principles of safety that some of the leading competitors are with their artificial intelligence platforms. The other thing is our devices are they're devices, right? They're not really robots yet.
Yeah.
While our overarching goal is to build sensors that contribute to the robotic sense of smell eventually down the road, these devices don't have a whole lot of capability in the beginning other than just smelling. So we control all the use cases that our sensors can go on. So for example, we don't want to put our sensors onto a device that can contribute to harmful cases for humans. We're very specific about who we license to, what we use our sensors on, and making sure that the AI backing it follows, human alignment guidelines effectively.
Right, right. Well, that's great to hear that you're thinking through some of these patterns. This brings me to some of the basic ideas behind how AI and data off of sensors are used by AI, and that's kind of time series mapping and pattern recognition. So that type of data is exposed by software that understands those kinds of patterns. So could you speak further to like what pattern recognition is and time series, especially for people who might not know what these things are?
Sure. So the best way I can think of time series is just if you were to take time right now and then have every 1 second a measurement of maybe my voice, right? Over 5 seconds, you're going to have five measurements. And that's a series of time points for the sound of my voice, right? So you have x-axis, which is time, the y-axis is the sound of my voice. Now you can imagine that in several different mediums where time series could represent, for example, in this case, smell. So we're measuring the magnitude of smell over time and how that varies with different air conditions, different aerodynamic environments, et cetera. Because
Right. So just as a small example, just on the smell side, I put a piece of frozen bread in the toaster, and then over time, the smell of that changes, right? Like if I capture a slice of, I just put it in, and maybe the smell is just starting to toast a little bit, and then it toasts more and more, and eventually it burns. Like the chemicals in the air will change as that toast burns, right?
yes, exactly. So our job is to try to figure out what's happening with the change of smell. Is it because of a reaction with the toaster, right? Technically, the toaster is doing work on the toast to make a chemical reaction that's indeed burning, or is it due to aerodynamic conditions that are changing? So it could be, that type of analysis, that type of intelligence is what we're trying to bake into our sensors to figure out what's going on to elicit this smell and how is the world changing around it in order to get a better idea of what the target compound really is and how it's changing with the environment.
Right. So being able to distinguish between like bread is just toasting and it's within the realm of general human consumption to where bread has turned into a cinder versus the toaster has an electrical fault and that's actually the smell of the toaster causing an electrical short, hypothetically. So those are three different kind of burning scenarios. Being able to distinguish between them is key, right?
Yes, precisely. So that's where extra modalities come in very handy, right? So if you have just your nose and you don't have prior knowledge about putting toast into a toaster and what that might cause, if that could cause a burning sensation, it's going to be very difficult to figure out how that smell's coming about. But if you incorporate vision, right, you incorporate some prior intelligence, knowing that you've toasted bread before, and it gives, this burning sensation if you leave it in the toaster long enough, that's where that intelligence starts to bake in. And that's what we're trying to do with our platform with the sensors is to incorporate multiple modalities, incorporate a prior world model that gives some intelligence about how these types of smells can come about in the world and really what the what's going on around the device, the sensor, the robot, etc.
Got it. Got it. Well, this is fascinating tech. What kind of market traction are you having right now with Theta?
So we are very focused on the healthcare industry to start, just because there's this whole sub industry within healthcare that is called breathomics. And so there's a lot that we can do within detecting various medical conditions. So I just mentioned a moment ago how we're going through a clinical trial for detecting lung cancer. That's going very well. We've looked at detecting other compounds such as pneumonia, influenza A, influenza B, other respiratory conditions. And we have other clinical trials that we plan to line up in the process to show that these sensors can be a very good status check on the well-being of your body. So healthcare is a very promising one. The gold standard right now for measuring any chemical within air is called a gas chromatography mass spectrometry machine, or
I'm familiar with it,
GCMS.
oddly enough.
Ah, okay, you poor thing. I'll be recruiting you for your advice and help then. But that machine is very large. It's the size of a fridge, it's several hundred pounds, it takes hours to perform an analysis. It's very good at its job, but it's a technology that's been around for decades. Now, that they send those things at the space station and they send similar technologies onto, other planets to look for life. Our sensors can look for those same types of chemicals that the GCMS and other spectrometry machines are looking for. And we're hoping that space-based applications will be the next phase of our development because there's a lot of signs that it can look for life. Our devices are really just a couple of grams and fit in the palm of your hand, powered by a lithium-ion battery. And that's, every kilogram you send up on a space shuttle or not the space shuttle, but any payload is
Yeah.
millions of dollars, right? So that's a lot of cost savings, a lot of user experience enhancement by just using a device that we can, hopefully enhance with our device.
Right, right. So I worked on sensors at Intel for a number of years before I left Intel. And so that's why I know about some of the work that you're doing there in terms of like what it takes to do sensor analysis. So I really respect the work that you're doing.
Thank you. Yeah, there's so much going on with AI right now, but it's so focused on these large language models. And I want to get people to realize there's so much more going on in AI. Like it doesn't all need to be in large language models. Yes, they're impressive. Yes, we should look into that. But sensing, I mean, that there's so much more that can be done in sensing. And so I'm glad to hear there's some sympathy for something besides large language models. So thank you.
Absolutely. So have you developed your hardware yourself, or do you have partners that you're working with to develop the hardware and software layers?
We developed all of our hardware and software in-house. Now, we don't
Wow.
manufacture it. We manufacture it at local facilities in the US, but everything is designed and developed in-house. We have patents on everything. So, yeah, all the intellectual property is within Theta, which is terrific.
Oh, that's really fantastic. And you have both a European arm and a US arm, right? So your company is kind of split between the continents, right?
Yes, we just recently merged with a company called Halitus, which was taking a very hardware-centric approach to detecting chemicals within air or this machine smell, and we were taking a very software-centric approach.
Oh, so it's a
And
perfect marriage, software and
e-
hardware. Yeah.
exactly. So now we've been able to magnify our ability to detect compounds within air because we have a very the yin and yang approach here. So that's been a terrific process.
Well, I know that you have a background at these large companies, and then you launched a couple different AI companies, and this one is really taking off. we have an audience of people who really care about startups, and a lot of them are startup leaders. So, could you share with us some of the things that you've done in order to get your startup kind of to the liftoff phase?
Yeah, the biggest thing that has helped me is when you start a startup, there's always an idea of what you have. And then, at least for in my experience, there's other ideas that come. And it's like, well, what if we do this too? And what if we do this too? And what if we do this too? And you start to, as you grow in capability, you grow in confidence of what you can do. And that can be a good thing, but it can also be a bad thing because you start to take on too much or you start to lose the vision of the product that you actually want to build.
Right,
And
it kind of diffuses. You start doing too many things and not doing anything particularly well. Yeah.
right, a startup will die of indigestion long before it will die of starvation, based on my experience and my observations. And so I found it helpful to use data to drive our product development. So what I mean by that is we try to collect data early and we also try to talk to customers early. So we'll build rapid prototypes and do an internal like alpha test on prototype devices or software and just try to get feedback on things right away. We're not doing a public launch. We're not doing anything that is a mass release. We just try to gather feedback rapidly and internally with a few clients, customers, partners, whatever that might be, and just get their brutal feedback on how we can shape the product. And we do this, sometimes multiple times a month, and just rapidly iterate, trying to use their advice, their testimonials, and their data to drive what our product should be from a usability perspective. But we also use, technology standpoint, actually use data to drive the development of certain aspects of the technology. There was about 15 different ways that we could have gone about producing the machine smell, and we selected one because of the data that really backed this specific direction. We gathered several different data sets, and we could have been in a much different place if we wouldn't have listened to the data and tried to work through some of the things that we were getting in the lab. So I think making data-driven decisions is key to really surviving as a startup, at least in my experience so far.
Got it. Thank you for that. Right, because a lot of startups don't know what to focus on. So, because there's so much to do, there is everything from onboarding your first customers to landing your funding to trying to build the tech out. And those three can be on separate paths all the time. And so, keeping focused is the key learning that I heard you articulate here. That wasn't
Yeah.
well.
No, you're totally right. That's one thing I think has been the key to success so far for Theta is we've been able to focus. I mean, you're not only going to have distractions of what you want to do and what you can do, but your investors are going to pull you in one direction. Your customers might pull you in one direction, and then you have your own internal vision as well. And there's this constant battle of where the true direction should be. And I
Mhm.
think there is something to say for the founder that is very bold and steadfast in their vision on how they want to move forward, because sometimes investors and customers just can't see it because all they can relate to is what's been done before. So I think there's something to be said to listening to the data and listening to your customers, but also listening to yourself and not compromising on your vision to some degree and making sure that you are building the thing that makes you want to get out of bed every morning.
Right, right. Fantastic advice. Thank you. So you mentioned earlier in the conversation AGI, artificial general intelligence. And I'll just ask you the big question. What's going to happen with AI within the next 5 to 10 years? Do you think we're going to achieve AGI or are there other outcomes that you're anticipating?
There are so many different definitions of AGI right now that I'm not certain which one's the real one,
Yeah.
but my definition of AGI is basically human level intelligence. I don't think we'll be there in 5 years. I think we might be there in 10.
Mm.
Yeah, so that's human level intelligence. Now, that's actually there's several ways you can answer that, right? Because if human level intelligence entails human experiences and all senses of human, then we might be a bit away, right? Because how can you pack human level experiences into a robot that's only been around for, 20 minutes, right? It's only been turned on for 20 minutes. That experience part, that emotional part, I think that's going to actually take years to bake into robotics and AI. If we're really going to talk about AGI, I think there's got to be a physical form to it. It's got to be a humanoid form. If we're talking that AGI means human level intelligence, I don't think you can have the human psychology without the body, because I think there needs to be the AI with the robotic humanoid form to really have human level intelligence. So the AI part, right, the psychology part, I think that will be developed within the next 5 to 10 years. But the body part, the physical part, is going to take a bit longer, in my opinion, to really marry those two up.
So our last question in this podcast is always, what do you dare to dream? What future do you think that you are creating, Kordel?
My life's goal is to be able to look back and say that if I didn't exist, technology would not be as far as it is today without me. So I just want to be able to say that I am moving technology forward and that I contributed to a better future, whether that's in AI, robotics, whatever that might be. And so I guess if you could dare to dream, it's just to dare to dream to move the world 1 inch closer to whatever that is, whether it's a millimeter, a kilometer, a mile, whatever it is, an inch, right? Just try to move it closer to a better future. And I think that's all you can ask for.
Fantastic. Well, really appreciate the conversation. Fascinating work that you're doing. Thank you.
Yes, thank you very much, Ned. Thank you to your listeners.
Okay, take care. Have a good day.
Hey, you too. Thanks, Ned.
Thanks to our guests today for their great insights on DARE, the podcast for innovators, entrepreneurs, and startup leaders. If you'd like your story to be featured on DARE, just contact us at info@darwaft.com. DARE is brought to you by Darwaft, the tech team that can make your vision a reality.